Hey guys, it's Miss Madeline. I just wanted to hop on here and talk to y'all about your math lesson for this week. You're going to be working in lesson 31. It's called Understanding Properties of Shapes. We're just going to talk about some vocab that you need to know, what you should be able to do when this is all over with, and I'm going to walk through some pages of the book with you. So by the end of this, you should be able to identify two-dimensional shapes and their attributes, just describing them, and you need to be able to compare and contrast those shapes. Vocabulary to know, we have a Venn diagram, and that's just a drawing that shows relationships among groups, and I put an example down here in the bottom. You have object 1, you have object 2, you tell things about object 1, you tell things about object 2. Where they cross is where you tell how they are the same. An angle is one of the corners of a shape where two sides meet. So you have two sides of a shape and they come together, they're going to form an angle. Now, whether or not that angle is an acute, obtuse, or right angle just depends, which brings me to square corner. Square corner is a 90-degree angle. It is just where two sides meet to form a 90-degree angle. And a little trick that you can use to know whether an angle is a 90-degree angle or not, take a piece of paper. Where those two lines come together, if they square up with that piece of paper right on the end, it is a 90-degree angle. If it is bigger than that, it's not. If it is smaller than that, it is not. So that's a little hint that you can use to figure out whether it is a perfect square corner or not. And I put an example down here under my Venn diagram. We have just an angle where two sides come together, and you have a square corner where they come together perfectly. I could line that up with a piece of paper and it would fit. It would be a perfect match. Going through the shapes, you have a rectangle. The definition is a quadrilateral with 4 square corners. Opposite sides are the same length. So right down here is our example. You have opposite sides. Those two are going to be the same length. Opposite sides right here are going to be the same length. A rhombus is a parallelogram with 4 sides that are all equal in length. Down here is my example of that. Then you have a pentagon, 2D, closed shape, 5 sides, 5 angles. And then a hexagon, 2D, closed shape, 6 sides, 6 angles. So there's our pentagon right here, and then here's our hexagon right here. And then a circle has no defined sides or angles. You cannot find a square corner in a circle. I think we know that. All right, so let's look in your book. You're going to be working, again, lesson 31. It's pages 332 and 333 in your book. So it's called Understanding Properties of Shapes. It says, think it through. How do sides and angles help you name shapes? You can count. If you're going to name a shape, you can count the sides. You can count the angles. That's pretty much your criteria for naming a shape. How many sides does it have? How many angles does it have? So if you look to your right here, you are going to have a 3-sided shape. It has 3 sides. You can count the angles. It has 1, 2, 3 angles. So a shape with 3 sides and 3 angles is a triangle. And I'm going to write on top of this so that y'all can see what I'm doing. There we go. All right, so once again, we have 3 sides, 1, 2, and 3, and you have 3 angles, and I'm going to put a dot on those angles. 1, 2, and 3 angles. 3, we know that tri means 3, triangle. All right, moving on, it says, what are other ways to describe the sides of a shape? So you have some sides will have all different lengths. So in this case, we have 1, 2, 3, 4. Would be a quadrilateral. They're all different lengths. It's just a quadrilateral. Moving on to our circle. Some shapes have no sides. Just like we discussed, a circle is not going to have any defined sides or lines in there. Third set, some shapes have 2 or more sides that are the same length. So it says sides A and B of the triangle at right are the same length. So if you look right here, we've got, a highlighter, sides A let me get it going. Sides A and B, those two sides are the same length. If we took C down here on the bottom and lined it up with it, they would not match. So side C is a different length than sides A and B. All right, shapes can have all sides the same length. If you look at our pentagon right here, if we deconstructed that pentagon and put all of those lines next to each other, they would all be the exact same length. You could also take a ruler and measure them to see if they're all the same length. Next bullet point, shapes can have opposite sides that are the same length. That would be a rectangle. You can take a rectangle, two sides of that rectangle are going to be the same length, the opposite two sides are going to be the same length. No matter which way you put it, if it's a rectangle, opposite sides are going to be the same length. You would know that's not true for a square because squares, all sides are the same length, not just opposite sides, all sides. So it says sides A and C of the rectangle at right are the same length. Sides B and D are the same length. So you've got B and D, they're same length, and A and C, they would match up. All right, moving on to page 331. It says, think, what are other ways to describe the angles of shapes? Angles that look like corners of a square can be called square corners. Just like I said earlier, shapes can have all square corners, no square corners, some square corners. We're gonna explore that. So if we took our rectangle, we took our piece of paper from earlier and we lined it up with those square corners, they would be perfect squares, 90-degree angles. They would be square corners. Those would be classified as square corners. So it says shapes that are not squares can have square corners too. So let's explore that. It says shapes can have some square corners. So here's a triangle. Unlike our triangle that we had earlier on page 330, it did not have any square corners. If we go back up here and we look at this triangle, there is nowhere on this triangle that I could take my piece of paper and line it up and it would match perfectly. That one did not have any square corners. But if we look at this triangle right here, it's shaped a little bit different. Still has three sides, still has three angles, still a triangle. But it has a square corner right here. So it would have one square corner. Now these two would be different. But this corner right here in the bottom is going to be, where it's pointed out, a square corner. I could take my paper again, line it up, I would have a square corner. Same thing with my pentagon over here. It's a shape, it has 5 sides, 5 angles. Is this, these two right here, our top and bottom, would not match up. This one right here on the top at our point would not match up. My two right here, yes, they would match up. Same concept, if we look at our one from earlier, this looks like it's mighty close. Mighty close. But if you look carefully, those are larger than my square corner. They would not be exactly 90 degrees. Would not match up. You can compare this pentagon right here to this one down here. This one has perfectly lined up square corners. It has to be exact. So this pentagon has 2 square corners. And then you have, shapes can have no square corners. So we have a hexagon here. The way a hexagon falls, it is not going to have a square corner. The way those lines are drawn, it will not have a square corner. So you should know now what a square corner is. Perfect 90 degree. I can take a piece of paper, I can line it up, it's going to match. That's a helpful little hint that you can always have with you because you always have paper with you 95% of the time. If it's more, if it's less, it does not match. All right, so question 1 says reflect. What are some ways you can describe a shape? So we know we can describe it by, does it have square corners? We also know that you can say how many sides does it have and how many angles does it have. Those are the big 3 criteria for describing the properties of a shape. How many sides, how many angles, does it have square corners, does it have any square corners? Like yes, no, some, all. That's what you're going to do. Sides, does it have 5? Does it have 10? Does it have 3? If it only has two sides, it is not closed in. It will not match up. It needs to be a closed two-dimensional shape. So 3 or more sides constitute a shape, with the exception of a circle. 3 or more angles. And that is pretty much the gist of this lesson 31. You can go on into pages 332, 333. It's pretty simple, pretty spelled out. If you can describe these shapes and describe the angles and describe their properties, you are set. If you have any more questions, I know that your teachers would be more than happy to help you. Just let them know what your question is, and they will get with you on what you need to do. I hope this helped, and I hope to see you guys soon. I'll see y'all later. Bye.